Hello guys, it's been a while and today I want to make a review from review what I learned from the fundamentals of semiconductor device. And so I wanna make a big draw, like step by step. So a lot of people wanted to make device scaling down because they wanted to earn a lot of money, and so it makes a lot of problem, and it's called short channel effect. Because gate length is gonna be short, and the thing is that it is it did really short, way short. So between channel and drain, retinal field is gonna be strong, so strong. So there are a lot of problem, and I wanna talk five things. First, punch draw. Second, bridge roll off. Third, drain induced barrier lowering. And fourth, velocity saturation and mobility degradation. And last, channel length modulation. And punch draw. It's like, the thing is, the depletion with source and body, and drain the depletion with drain and body, it's gonna be overlap. So it looks like even if you turn off the voltage, but when you check ID current, current of drain, it looks like have really small current. So, and also as you can see, threshold voltage is gonna be down. So it's called VT roll-off. And when you put voltage in drain, when you put bias in drain, it's gonna be barrier rolling. I mean barrier with source and channel, and drain and channel, like this. And you should draw conduction band between source and channel. When you put voltage of drain in here, you can see the conduction band is gonna be down, but when you see short channel, it's gonna be more short. More barrier is like more lower than long channel device, so it's big problem. And when you put when you see velocity saturation, mobility degradation, it's like even if you put high voltage in drain, velocity saturation is like, when you see saturation point, I mean pinch off point, you can see this, it's like x 제곱, but when you see short channel, you can see this, it's like linear. So it's gonna be big problem when you put even if you scaling down, but velocity is almost same. Yeah, it's gonna be big problem, isn't it? And let's talk about last thing, short channel modulation. As you can see, when you draw ID-VD curve, even if you are in the saturation part, you can see current of drain, it's gonna be grow it's gonna be increase because channel length is gonna be short. Yeah, so the solution, we have two solutions, like using junction engineering, LDD, lightly doped drain, and pocket implant. Light doped drain is like this. As you already learned, that we know that the point of big potential is surface of junction. So we gonna make lightly doped. So it's gonna be more. It's gonna be more. When you see this, when you put lightly doped drain here, you can see it makes E field more weak. Yeah, and junction engineering pocket implant, it's like this. You can, when you have NMOS device, you can make hollow junction in here, like heavily doped of P type. You put here, so it also makes sorb, punch throw, and a lot of things, and all of the bridge roll off, drain induced barrier rolling, yeah, and a lot of, so it can also help us make E field more rolling. So and we want to talk about gate induced drain leakage. When, as you can see, when you see NFET, you can draw band diagram like this, and even if you didn't put anything, any voltage, any bias, but you can see band to band tunneling, because because it's very increase, and pipette is also same. And when you see last, we gonna talk about source drain series resistance. It's like this. When you have long channel device, we don't have to think about source drain series resistance, because the oxide resistance is very big when you think about source or drain. But when you're gonna make scaling down, we should also think about source drain series resistance. And thank you for everything.